All right, guys. So in this video, I'm going to go over the questions from the review. What you're going to find out in this review, especially for the first page or the first couple, is that I really am focused on, do you know the formulas? And there's a reason why we had the formula quiz before having this test. So hopefully you've done well in that quiz, so that way you're prepared for the test. Because if you don't know the formulas, then it's going to be a pretty tough thing to do. So we'll be going over in the review days these different formulas. You'll be taking the quiz over it. So if you haven't started putting in the time to memorize them, hopefully it's something you're going to do soon. All right, so the first one says, use identities to simplify each expression. So this actually is one that you will have been tested on already. All right, so if you look in the basic 8 trig identities here in kind of the middle left, you can see cosine over sine, which is the same as cotangents, right? So understanding that if I divide cosine of x over sine of x, I get cotangent of x. Let's do number 2. Another basic identity. This is one of your basic 8 identities. This is a reciprocal identity. You don't see it exactly over here, but I've been trying to stress that sine and cosecant, cosine and secant, and tangent and cotangent are all reciprocal identities. So when you do 1 over one of them, you can just write its reciprocal, and the reciprocal of cosecant is the sine of x. This is probably the most common one in terms of the use of the Pythagorean identities, right? Again, it's still in the basic ones, but these 3 on the right-hand column in the basic 8 trig identities are called the Pythagorean identities, all right? And so the sine squared plus cosine squared is probably the most common one that we'll be using with those 3, and that's equal to 1. So as you can see, the first 3, you really didn't have to know or do anything algebraically with those identities. You just needed to have them memorized. Now, number 4, there will be some manipulation of one of the identities. I see secant squared and I see 1. If you go to the middle or the second one of the Pythagorean identities, it's 1 plus tangent squared x equals secant squared x. All right, so I'm going to manipulate this with algebra to make it look like my number 4. So I'm going to move that number 1 to the other side with subtraction. And when I do, that leaves me with tangent squared x equals secant squared x minus 1, which is actually what I have, right? You can see, I'll highlight it for you, right? I have secant squared x minus 1 in my algebraic manipulation of this identity. So I'm just going to write down what it's equal to, and that's equal to the tangent squared of x. That's number 4. All right, now number 5 and 6 are the questions that are going to have you deal with the sum and difference identities. And these are actually both sums, but you need to make sure you have all of them memorized in these sum and different ones. And there's also a tangent one over here, so don't forget that there is a tangent for sum and difference as well. So there's really 6 is the way I view it. All right, so the first one says sine, and I'll just go ahead and make this A and this angle B, and we're doing A plus B. So let's go ahead and just write the formula. The sine of A plus B is the sine of angle A times the cosine of angle B plus the cosine of angle A times the sine of angle B. And the way I memorize this is with sine, your symbol, so whatever sign is in the middle there, that's going to be your symbol in your actual equation. And then what you do is you start with sine. As you can see, we started with sine of angle A, and then you change the order of the trig functions. But you'll notice that in all of your formulas, the order of the angles never changes. It's always A and then B, always A and then B. All right, so just keep that in mind. You're never going to change the order of the angles. All right, so this is going to be the sine of pi over 2 plus x equals, so sine of pi over 2 times the cosine of x plus the cosine of pi over 2 times the sine of angle x. All right, now I can't do anything with the cosine of x or the sine of x, but I can simplify the sine of pi over 2 and the cosine of pi over 2, right? I should know these from my work with quadrantals. So again, I've got my quadrantals here on my formula sheet, all right? And again, if you don't have this memorized, be prepared. It will be asked of you on the test. And I'm looking at the sine and cosine of pi over 2. So pi over 2 is up here at the top. Remember, cosine is going to be the value in the x-coordinate. Sine of my pi over 2 will be the value in the y-coordinate. So the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So this is going to be 1 times the cosine of x plus 0 times the sine of x. So if you end up multiplying by 0 on that right-hand side times the sine of x, that's just going to be 0. And 1 times anything is just that anything. So this all becomes equals the cosine of x. All right, so that's how you do number 5. Let's try number 6. All right, again, I'm going to be using first my formula for the cosine of a plus b. So let's go ahead and just write down that formula. All right, so the way I memorize this is you're going to do the cosine of both. And then because it says cosine here at the start, you do the opposite sign. So I'm going to do subtraction, right? The opposite sign of this addition symbol. So subtraction, and then you do the sine of both those angles. So again, you can look here, right? That is the third one here in this box. So the cosine of a plus b is cosine of a, cosine of b minus sine of a times sine of b. All right, so let's plug in for the stuff we have, which is cosine of pi plus x. So cosine of pi times the cosine of x minus the sine of pi times the sine of x. So again, quadrantals. This time I'm worrying about pi. So if I look at pi over here, it's my farthest left point. The cosine of pi is -1, and the sine of pi is 0. So the cosine of pi is -1, and the sine of pi is 0. All right, so similar to what we had on the previous one, the stuff on the right-hand side is going to be 0. 0 times the sine of x is 0. And -1 times cosine x gives us the opposite of the cosine of x. All right, so be prepared to have those formulas memorized, but also be ready for some questions using quadrantals. So that's it for 5 and 6. Okay, now let's go to the second page. The second page is going to start by doing some work with double angles. All right, so you'll notice I want to find the sine, cosine, and tangent of 2 times my angle theta. All right, so first thing I'm going to do, because I know I'm going to need all 3 of my trig ratios, sine, cosine, and tangent to do those. So the first thing I do is I actually want to make the triangle. All right, if I make the triangle, it says theta is in quadrant 1. All right, so here's my theta. I'm being told that the sine of theta is 6/10, right? Remember, you are going to need to think about SOHCAHTOA on this one. All right, so sine is opposite over hypotenuse, so my y value is going to be 6, and my hypotenuse, or r, is going to be 10. So that leaves me trying to find x. If you don't know how to find x, make sure you know the Pythagorean theorem. If you don't know that this is like a special one, so I have x squared plus 6 squared equals 10 squared. So that's x squared plus 36 equals 100. Subtract the 36 to the other side. You get 64. And hopefully you know that the square root of 64 is 8. The reason I'm not concerned about if it's negative or not is because we are in quadrant 1. All right, so being in quadrant 1 means everything needs to be a positive. All right, so now I'm able to write down my 3 trig ratios here. So we had the sine of theta is equal to 6/10. We can find the cosine of theta now, which is going to be adjacent, so 8/10, adjacent over hypotenuse. And the tangent of theta, which is going to be opposite over adjacent, so 6/8. So again, the idea here being that you need those 3. If you want to reduce these, you can reduce them all. You're going to get the same thing. I'm not worried about that. I'm not going to reduce them, but I will be using Desmos here in a little bit to make sure that I can find what these are. So let's start with the first one, which is the sine of 2 theta. Again, if you need the formula sheet during the review, that's okay, but you will not get it on the exam. So that's that first one up here with the double angle identities, which is the same as 2 times the sine of theta times the cosine of theta. So if I plug in what I know, the sine of theta was 6/10, and the cosine of theta is 8/10. And you could probably do this in your head because the numbers, with those tens may be a little simpler. But again, we'll just show you with Desmos. All right, so go to my calculator here. And I'm going to type in 2 times 6/10. and then times 8/10. Get a fraction, and you get 24 over 25. So 24/25. Now, when I do the cosine of 2 theta, remember this one has 3 different formulas, right? And you can use any of them. Now that we've done the pre-work to find all 3 of those trig ratios, sine, cosine, and tangent, you can actually use any one that you want, right? You could use the first one even, right? Because you know cosine and sine of theta. You could use the second one. You could use the third one. What I'm going to do, because how I taught you guys in the lessons, was if you're given the sine of theta, I'm going to use the one that has sine, which is the last one, 1 minus 2 sine squared of theta. So 1 minus 2 times sine squared theta. So the way you plug this in is 1 minus 2 times, so put the sine of theta, which is 6/10, and don't forget to square it. So going to my calculator, I'm going to type in 1 minus 2 times 6/10, all of that squared. All right, so 7/25 is going to be the cosine of 2 theta. All right, so the last one, which is the tangent of 2 theta, all right, going to your formula sheet, you can see it's this bottom one here in the formulas for tangent. You've got 2 times the tangent of theta, so 2 times the tangent of theta over 1 minus tangent squared theta. So 2 times, and again, if you're using the reduced value of 3/4 for this fraction, that's fine. So 2 times 6/8 over 1 minus 6/8 squared. All right, so go to your calculator. All right, so I'm going to move this to the side. So I have fraction 2 times 6/8 over 1 minus 6/8, all of that squared. All right, get the fraction, and you get 24 over 7. All right, so that's all 3 answers that they wanted. They wanted sine, cosine, and tangent of 2 theta, and we got all 3. So make sure you're ready for the pre-work like we practiced before, all right, and also finding all 3 of those without using any formulas. Okay, the last 2. Now, the last 2 is what we did most recently. These lessons at the end were about solving trigonometric equations. And again, the key thing here is you're trying to isolate the trig ratio or trig function. And if it's not in sine, cosine, or tangent, make sure you use the reciprocal to get it to be one of those 3. And then really it comes down to, do you have this table right here memorized, right, from our first unit, as well as the all students take classes. All of that's going to help you solve these equations. All right, so first thing I do is I'm going to add 2 to move that minus 2 to the other side. So that leaves me with 4 times the sine of theta equals 2. And then I want to get sine by itself, so I will be dividing both sides by 4 to get the sine of theta equals, and I will reduce this to be 1/2. So I've isolated it. It does say sine, cosine, or tangent, so we're good there. So now I'm ready to find my reference angle, which is sine to the negative first power of 1/2. So this is essentially telling my brain, all right, I know the sine of my angle has to be 1/2. Go to your table, which angle of these special angles is going to be 1/2. And you'll see it says pi over 6. I'm not that concerned about if you put pi over 6, but it does say in the instructions to use degrees. So pi over 6 is the same as 30 degrees. Now, probably the most difficult part here will be figuring out which quadrants you're going to be drawing your answers in. And because when I look at my check mark over here, right, this checkpoint, I notice that it says the sine of theta is equal to positive 1/2. So I'm looking in my all students take classes to determine that these angles are going to be in the first quadrant, right, as well as in the second quadrant, because that's where sine is positive, right? Everything's positive in the first quadrant. Sine and cosecant are positive in the second. Tangent and cotangent are positive in the third. And cosine and secant are positive in the fourth. All right, so one of my answers is actually the reference angle of 30 degrees. In your practice, hopefully you remember that when you're in the second quadrant, you actually have to subtract 180 minus the reference angle to get our answer of 150 degrees. Right? So that's it for number 8. Now, number 9 is essentially the same thing, just, obviously it's going to be a little bit different, but the process will be exactly the same. I'm trying to isolate cosine. So let's divide both sides by 2. And that gives me the cosine of theta equals the opposite of the square root of 2 over 2. I've isolated cosine. It says sine, cosine, or tangent, so I don't need to do any reciprocals. So that's my check mark. Now, what you'll notice when I find my reference angle, and I'm really trying to stress this in class right now, is that I actually put just the positive version of the trig ratio. So I know it says in my checkpoint that it's equal to negative square root of 2 over 2, but I want to find the reference angle, so it's going to be in the first quadrant. So it will be positive. I'm going to my table, right? This is actually pi over 4 for my angle. And again, if you put radians, I'm not that worried about it, but pi over 4 is the same as 45 degrees. But now, when I decide where I'm drawing this, I go back to my all students take classes, and I need to figure out where cosine is negative, all right? So cosine is actually positive in the first and the fourth quadrants, right? All and the cosine. So it's going to be negative in the second and the third quadrant. So that's where I'll be drawing my thetas, my answers for this one in the second and in the third. All right, and again, you've practiced this a ton. So the answer is going to be 180 minus the reference angle and 180 plus the reference angle. If you're using radians instead of 180 degrees, you'll be using pi. So one of them is 135 and the other is 225 degrees. All right, guys, that's it. I hope you see with this review that I'm really just essentially, saying if you don't know the formulas, if you don't have those memorized, it's going to be difficult to do well on this. So put in the time to make sure you do well on the formula quiz and have them ready for this test. Good luck.